Hi, everyone. Well, this is a presentation for a project. It's called Detect and Track Oil Spills in the Gulf of Mexico using PACE data. At the very beginning, we were thinking about tracking the oil spills in this Gulf, but since we are limited to the last 2 years since PACE was launched, at the very beginning, we couldn't find like a huge event in the Gulf of Mexico, so the project evolved to this. To detect and track just oil spills using PACE data. We moved to another regions. We try to find the signature of the oils in different places. Okay. Well, the collaborators for this project were Santiago, Jorge, Danalie, me, Alfredo, and Abdulmajid. I think he was like some trouble, scheduled trouble, because he just showed up a couple of times. I want to thank from the very beginning to Eli and Ryan for all the amazing job that they did during this HackWeek, because it was amazing. And also we want to thank all the people that made this possible. And also we want to thank Amir and Kelly, who were very close to us, helping us, giving us some references, papers, some feedback. Just thank you all. Okay, so introduction for our project. Major hydrocarbon production regions, such as the southern Gulf of Mexico, face a continuous risk of oil spills from offshore infrastructure, operational activities, and natural seepage. These spills pose serious threats to marine and coastal ecosystems. Our project aims to leverage PACE hyperspectral imagery to detect, track, characterize oil spills, estimate the leak extent, and contribute to monitoring and early warning systems. Well, why is this important? We have like huge impact for spills, since the environmental impact and socioeconomic impact, such as economic degradation, biological communities, water quality, economic losses, maritime routes, and coastal populations. So this impacts in a lot of things. So this is why we think this is so important to be studied, and when they happen, to be contained and to face the impact of the spills. So the methodology we choose was obviously using PACE reflectance databases. We focus on level 2. We also work with level 3 products, but we were like moving from one to another after we managed to find some signatures on level 2 data. And using Eli and Ryan's coding tutorial, we identified and accessed products and files to identify features associated with documented oil spills events across different regions. Like I told you before, we work on regions outside of the Gulf of Mexico. We worked in like 6 or 7 regions for matter of time. I am only showing you like a few of them, but after defining these areas of interest, we established transects across the affected regions and analyzed surface reflectance along them to evaluate spatial variability and to identify potential oil signatures. The spectral data and sensor capabilities were important because, well, the products for PACE have like a spectral resolution for visible and near infrared. This coverage enable detailed analysis of oil-related reflectance anomalies, but we found in the literature that there are some features, especially near 1.2, 1.7, and 2.3, that the spectrum shows like an absorption of light. We know that PACE data has not like a high resolution in this area, so we were just focusing on trying to find like a similar spectrum, knowing that the resolution is not the best for the higher wavelengths, but maybe trying to find like a similar shape. So this is some of the regions we work on. This is the Malacca Strait during an oil spill on June of 2025. So also we find in the literature that for some slicks, the spectrum peaks between 500 and 580. So a lot of the spectrum that we analyzed had this. So this was like a first glance that maybe this spectrum could be showing us the presence of the oil, since we struggle a little bit like for the true color images, trying to identify if it was oil, if it was something else. We had some trouble also because of the clouds, because of all the things that maybe we do not know about, like all the organic matter that might be here. So we work on that. For the other region that we should work with, this Manila Bay for a slick during July of 2025. And I have this date, and I have another one, and spectrum look slightly, well, not slightly, very different. This one shows a peak near 100, but I mean 1,000, and it might have like the absorption that I showed you in the previous slide. So we do not know for sure if it is like the oil spill could be, since we have on the region and the dates that we find it is documented, but we cannot be sure if it has the presence of the special feature of absorption. It could show at 1.2. Also, during this is for 4th of August. This one is for 7. And the spectrum changes a lot, and it shows again the peak that I told you before between 500 and 580. So both of these features, the peak here at 1,000 and the other peak between 500 and 580, could suggest that this could be the signature for the oil spills during this event. Finally, this event at Lovina, this one is in the Gulf of Mexico, has this peak at 1,000. It is some of the points around here. Also, we talk about what we see here in the true color figure, because there are some colors. There's a lot of green here, and we can see the signature here, all the green, I mean the yellow spectrums that are near the coast and near the green spot. So we need a lot of work with this, and it's where our conclusion are on. The analysis reveals that evidence consistent with the presence of material exhibiting reflectance characteristics similar to oil within the study areas. However, these findings are subject to important limitations, including persistent cloud cover, the satellite SWAT coverage, and the availability of spectrum resolution with constrained unambiguous detections. Despite these challenges, the observed spectral anomalies indicate that the approach is sensitive to relevant surface features. We think that we using this, combined with complementary methodologies, additional data sets, and the evaluation of other environmental variables, this framework could substantially improve confidence in the identification of potential oil presence. These are our references, and thanks again.